Hello students. In this chapter 6, factors of algebraic expressions, we are going to look at how to factorize various algebraic expressions. So let's start right away. First of all, let's understand what are factors. So let's take a particular number like 6. So this number can be written as 2 times 3. Right, 2 times 3 is 6. So then we call 2 and 3 are factors. They are factors of 6. Likewise, if we take 10, you can write it as 2 times 5. So 2 and 5 are factors of 10. Take number 30. We can write this as 6 times 5. Obviously, 6 and 5 are factors of 30, but we also know from this statement 6 can be written as 2 times 3 and times 5 will make this 30. So we can essentially say 2, 3 and 5 are factors of 30. So this notion of writing a particular number or something like an algebraic expressions in terms of multiplication of two terms or two numbers, then we call those two terms or multiple terms as those multiplications. Now, here in the case of 30, we can write it as a multiplication of three numbers. Then those three will become factors of that, the product, the final number that you get when you multiply. Likewise, you can write the same when it comes to algebraic expressions. Let's take an example like what is given here. So when you have something like 2x plus 2y, we can write this as 2x plus y. Now here it's basically a multiplication in the middle. So we took out the 2 here, and essentially what this means is 2 by x, 2x, and 2 by y, 2y, which is what became here. So we can basically, this and these are same. So when what we can conclude out of this is 2x plus 2y. The factors of this are 2 and x plus y. Typically we write it in this way. And we call this process of writing a full expression, an algebraic expression, as product of two terms factorization. So 2 and x plus y are two factors. So let's go into more examples. Like if you take a look at the 3x plus 12. If we take 3 out here, it becomes x plus 4. So then the factors of this particular expression is 3 and x plus 4. So we can write it this way. And like product of two different terms or sometimes three different terms. Let's do a few review exercises, and that way we can solidify our understanding here. Okay, so let's take this example here. If I just zoom a little bit for you to see. Let's take the question number A. It's the easier one. In this case, we have two unknowns like x and y, right? So the common term here is we can't take 8 out because 12 doesn't divide by 8 clearly. So what we can do is we can take 4 out. Then the remaining thing is 2x, because 4 times 2 is 8. So if you multiply this, only this comes. And 4 times 3 is only y. 4 times 3 is only 12. So we can write it like this. We can't factor this any further because 2 and 3, you can find a common factorization there, right? Okay, so that's the final thing there. And let's find, maybe we'll do E and 4p minus 20q, right? So you take 4 out, then you have p minus 4 times 5 is 20. So you can write it this way. And as I mentioned, it doesn't have to be just two terms like this. You can have more terms. So let's take h. I'm not going to do everything, but let's take this 12a minus 8b plus 4. Here you can take easily, you can see 12, 8 and 4, the common term is 4. So you can take 4 out, then you get 3a minus 2b. 4 times 2 is 8, right? Take these two, you get this. And 4 times 1. And see how we have retained the minus and the plus according to the original expression. That you need to keep as is. Let's do maybe q. It says 6ab minus 9bc. Now what's the common between 6 and 9? Maybe 3, right? And 3, and then you have 2 remaining. We don't have a's in both, so we have to leave a there and 2a, but b we can take out. So basically you can write b here. Essentially, so let me put it this way, 3b, and what's remaining here is 2a. 3 times 2, 6. This a is here, this b is here, minus 3 times 3 is only 9, because here b we have already taken out. So what's remaining is c. So we have to write it that way. Okay, and let's do u, the last one. It looks a bit complex, but essentially it's not. So here the s squared, s to the power of 2. So basically s squared means s times s, right? So here this case, again 6 and 12, we can take 6 out, um, and also s out, because both terms have s. So we can take s out, but I can only take one s out, even though this has s times s, right? So when I do this, 6s means what's remaining here is only 1, minus 6 times 2 only 12, but one s we have taken out of this s times s, we have taken one out, so we have to leave the other one in, and t. So this is the answer for that. Okay. And next thing what we are going to talk about is factors of algebraic expression with 4 terms. So let's get into that very quickly. Okay, so looking at this example here in this side, okay, uh, if we have something like ax plus ay plus bx plus by, now the obvious thing is to look at these two and these two, because it seems like there is a common value between these two terms, which is a. So when I take a out, it becomes x plus y, and then this plus you have to remain, and here in between these two terms you have to take b out and x plus y. Now take a look at this entire thing. You see something common, right? What is it? X plus y is common. So if I take x plus y out of that, for this term what is remaining is a. So x plus y times a is basically this, a times x plus y, and you have to bring this down b, and out of this term we have taken x plus y out. Now what's remaining is b. So essentially, which means we can write this as this. Pretty easy, right? So let's do a few examples, then you will get it right. Okay, so exercise 6.1, I'm going to take the first one. Let's take A. So it says ax plus ay plus 3x plus 3y. You see the same pattern like the previous one, right? So we can write the first two, we can write in this way. Here we can take 3 out, then it becomes x plus y. Out of this we can take x plus y out, then what's remaining is a plus 3. So factorizing uh, that way. So let's do C. It says mp minus mq, then other one is np plus nq. It's okay. We take m out of this, it becomes p minus q. M times p is mp, m times q is mq, and we retain this q. Now here this part is little tricky because it starts with minus, not plus, like in previous cases. But what we know is obviously there seems like n is a common term. So better thing is to take minus n out. Then for this term, minus is already there. So what's remaining is p. But now for this plus, we have already taken minus out. So remember, minus times minus only plus. So this becomes minus q, which is obviously easy for us to now see. P minus q is common between these two. So we can say p minus q out, and what's remaining is m minus n. So this is the factor of that. Let's do f. So that says y square minus 7y minus 2y plus 14. Pretty easy again. So we can take y out, even though this is y square. So we have y left there minus, and we took y out of that. So it's going to be minus 7. Here in this case, we are going to take minus 2 out. So then this becomes y. 2 times y is 2y. And this plus, because of this plus and this minus and this plus, this has to be minus. And you see 2 times 7 only 14. So now you see the common term again, y minus 7, y minus 2. Even though you can write it the other way around also, that is also okay if you want to write it that way. So both these are same. It's like 2 times 3 is equal to 3 times 2, just like that. So let's do one more. Maybe we'll do j. Yeah, let's do j. It says ax minus a minus x plus 1. So here we can take a out, then it becomes x minus x. So x minus 1 inside. So here if we take minus 1 out, then the remaining one will be x minus 1. So the factor will be x minus 1 times a minus 1. It's pretty easy. Okay, so the last part of this particular chapter is in fact uh, factorizing trinomial expressions. So it's a very involved part. So let's see how. First of all, what is a trinomial expression? Trinomial expression is usually an expression, that algebraic expression, that has three terms. Something like this that you see here, x square plus 7x plus 12. We can't simplify this any further when writing it as a trinomial expression, because x square is a different type than 7x, because this has x square and this has 7x. You can't combine those two. Likewise, we can't combine x square and 12. We can't combine 7x and 12 because those are two different types. That's why this is a trinomial expression. If somebody had something like x plus 7x plus 12, this is in fact is not a trinomial expression, because we can add these two, x and 7x, because those are of same type. So we write it as 8x plus 12 and so forth, right? So then it's still not three terms there. Even though here it's three terms, Why we call it a why we call this as a trinomial expression? Because three different types of terms, even though this also has three terms, but we can simplify it down to two terms, right? So that's the important thing to know. Well, so now how do we factorize this kind of a expression? So is it possible? First of all, sometimes it's not always possible to factorize a trinomial expression. Sometimes it's possible. So that's what we are going to do. um, for example, if you take this particular thing, this particular term, we can write the middle 7x as what? As you can see here, 4x plus 3x, because this is 7x plus 12. Now if we factorize these two, we can take x out, x plus 4, and here 3 out, and then x plus 4. Why? 3 times 4 is 12. 3 times x is 3x. X times 4 is 4x. X times x is x square. Now we see a common term here, x plus 4 plus x plus 3. Now you may ask me, to write how did I decide to write this term 4 plus 3x for this 7x? Why didn't I choose to write x plus 6x or 2x plus 5x? That is the key thing to know or understand or derive for you to factorize. So that's what we are going to see, and how to decide that. How should you break that middle term into two different terms to make this factorization easier. So that for that we need to have this number 12 and 7 involved. So if I take 4 and 3, I can write 7 as 4 and 3, 4 plus 3, and I can write 12 as 4 times 3. Okay, but if I had chosen this, it will be 1 plus 6. But can I write 12 as 1 plus 6? That is not the case, right? So this doesn't work. About this one, we could have written 7 as 2 plus 5, but 2 times 5 is not 12. That's why we chose this. So that's the key part to understand when it comes to factorization. So let's do a few examples, and that way you will understand. So exercise 6.2, we will do that, and you will understand what I'm saying here. Okay, let's do the question A here. X square plus 9x plus 18. It's easy now. Take, as I mentioned previously, 18 and 9. How can we write it in two terms? This has to support the addition, this has to support the multiplication. The easier thing is 6 times 6 plus 3, right? 6 plus 3 is 9 and 6 times 3 is 18. So that's the two numbers that we need to break this 9 into. For example, 6x plus 3x plus 18. So then here I can take x out for these two, x plus 6, and out of this I can take 3 out, then x plus 6. So then out of this we can write it this way. Perfect. So let's do I. P square plus 6p minus 16. Now again, here we need to see how 6 and 16 work together, but this is minus 16, remember. So to do this, you can't do like this, 6 times 1, sorry, 6 you can't write it like 5 plus 1. 5 plus 1, here 5 times 1 doesn't set. But here the key thing to understand is minus. So it doesn't always have to be 5 plus 1, 4 plus 2, 3 plus 3, nothing like that. You can also write it like minus 8 plus 2. Minus 8 and plus 2 is like minus 6. Think about losing 8 rupees and gaining 2 rupees, and you are at loss of 6 rupees. So that's why it's or rather, we shouldn't write it like this. We should write like 8 minus 2. 8 minus 2 is 6, right? And here 8 times minus 2 is minus 16. So that's what we have to write this with. 8p minus 2p minus 16. Here we can take p out of these two. So then it becomes p plus 8. Out of this, we take minus 2 out, then p plus 8. So the answer for this is p minus 2, p plus 8, taking p plus 8 out, right? So that way we can do. So let's do maybe n quickly. Okay, n is k square minus 10k plus 25. So again, how do we write minus 10 and 25? Right, it's easy to think. Right now this is minus 10 and this is 25. The easier thing is minus 5 minus 5 is minus 10, and minus 5 times minus 5 is plus 25. So we had to write 10k minus 10k like that. So minus 5k times minus 5k plus 25. It becomes easy when you practice. So when you take k out, it becomes k minus 5, and when you take 5 out, it becomes k minus 5. And this is basically k minus 5 and k minus 5. And you see something right here, k minus 5 times k minus 5. We can also, in later we will write this as k minus 5 squared. And we will also see when something like this is given, how to write this, and how when we look at this right away we know it is something like this. That also we will have to master and get to know, right? So let's also do one more, maybe r. Here the thing is, they have written confused you a little bit, right? Usually this term comes first. It doesn't matter in how in which order you write these different terms. So you write it in your own way if you want to. Like for example, you can write it in this way, right? Now we need to see how minus 5 comes and 54 comes, right? For example, I can see 18 times 3 is 54, but can I write it in that way? Yeah, you can write it in minus 18 plus 3 is minus 15. So that is how I should divide that minus 15. So I should write it as minus 8y plus 3y plus 54. Out of this, if I take y out, it's going to be y minus 18. Okay, that's wrong, right? So it's minus 8 plus 3 is minus 15, but minus 8 times 3 is not plus 54. So this is wrong. The way that I approached was wrong. So let's go back again. Okay, so I'm gonna get back to that again. Okay, so we have minus 15 and 54. How do we get to this number? Okay, so we can write this minus 15 as minus 9 minus 6, and minus 9 times minus 6 is plus 54. So that's what we need to write with. So minus 9y minus 6y plus 54. So we take y out, y minus 9, and then taking 6 out here, it becomes y minus 9 here. So now this answer is y minus 9, y minus 6 times y minus 9. Okay, so that's how we do it. Factors are expression written as two squares, difference of two squares. So that's what we are going to look at next. Okay, so let's see this. X square minus y square. This thing is, you can write this x square minus y square as x square plus xy minus xy, because these two nullifies, right? And then the remaining y square, and then we take x out of this, we can get x plus y, and if you take minus y out of this, it becomes x plus y. So see, it is x plus y minus times x minus y. When you see something like this means you can get to this. So for example, if somebody gives you a number like 5 plus a and 5 minus a, you can easily write this as 5 square minus a square. You should remember that. So which is 25 minus a squared, right? And if somebody gives you k plus m, k minus m, then you should know this is equal to k square minus m squared. Okay, so that's what it means. So to find these numbers geometrically, try this square method and see. I will leave that to you as an exercise if you want, but we can try do that. It's okay. We'll see that next. We can geometrically prove this as well. How do we geometrically prove? What does it mean by proving geometrically? Geometrically proving means proving by your shapes. Now, for example, if this is a square with width a, width a and length a, the area of this is a squared, right? Because it's a square. But if I have a smaller square within this, b and b, this area is b squared. So the remaining area, let me put that way, remaining area, this one, then you can write that as a square minus b square, because you have to take this square's area, which is b square, out from the total square, which is a square. So the remaining area's area value is what a square minus b square means. Now let's draw the same thing like this. Now this is b, right? This length is b, this width is also b. Now this entire height is a, and this entire thing is a. But important thing is, let's divide it. Let's divide it like this. Okay, then what is this length? This entire thing is a, and this part is b, which means this part is b. This entire thing is a, so this part is a minus b. So what is the area of this then? We know the width, which is a minus b. We know the length, which is a times a minus b. Okay, and then finding the area of this part up to here, this square. We know the height, which is b. What is this length? We know the total length is a and this length is b, so this is a minus b. So height is b, the width is b, and length is a minus b. So it is b times a minus b. And addition of these two
First, use bus
is
recognition to unlock the device.
addition of these two is the area. And this we know there is a common term a minus b plus a plus b. Sorry, it is, which is same as this then. That is how we prove it geometrically, right? So likewise, if somebody gives you a question as to, let's say, this exercise 6.3, let's do a few examples there. Okay, let's do a x square minus 100. When you have it like this, we can easily write x square 100 as 10 squared, because 10 times 10 is 100. So then we know we can write this as x minus 10, x plus 10. Likewise, if I do f, which says 64 times y squared, this is 64 is 8 squared and y squared is like this. So then the answer for this 8 minus y, 8 plus y, right? Let's do g, x square time minus 4y square. Here the trick thing is x square, you have to write it like this. Here this 4y, 4 times 4 is 2 times 2, so I can write it like 2 square y square, and then I can write this 2 square and y square as x square 2y square. Both these terms I can combine and write the power as 2, or the index, right? So then we can write this as x minus 2y. This one is like x square minus y square, but instead of y we have 2y. So x minus 2y plus x plus 2y. Likewise, if I do L, which is 25a square b square minus 9c square. So this I can easily write 5ab square. 5 times 5 is 25, a times a is a square, b times b is b square, minus this is 3c squared. So this part I can write 5ab minus 3c, 5ab plus 3c, something like this. Pretty easy, right? Okay, so that concludes our thing here. So maybe let's just try the last one here. Is there an exercise? Yeah, some miscellaneous ones. So let's do this fourth one. So what does it say? So it says join each algebraic expression in column A with product of its factors in column B. So obviously it's very easy, right? So if I just do the last one, x square divided by 25 minus 1. This we can write x square divided by 5 square minus 1 squared. And this one, x divided by 5 squared minus 1 squared, and that's what it means. X divided by 5 minus 1, x divided by 5 plus 1, which is the first one, correct? And I will leave the rest as the exercise for you, and the next one will be axioms, and I will see you folks in another video with axiom lesson. And until then, and goodbye for everyone. Thank you very much for watching this video.